Okay, good afternoon friends. We will continue with Laplace transform. Today we will have some tutorial session. We will be solving some problems employing Laplace transform. Let us take simple functions. What will be the Laplace transform of 1 by 2a squared sin at minus sin at? What will be the Laplace transform of this? So, this one can be written as 1 by 2a square. What is sin hyperbolic at? E to the power at minus e to the power minus at divided by 2 minus sin at. So, it is pretty simple. 1 by 4a squared e to the power at will be 1 by s minus a minus 1 by s plus a. Is that all right? Minus 1 by 2a squared sin at will give you a divided by a squared plus a squared. Is that okay? So, if I add these two, it will be s plus a minus s plus a. So, twice a. So, that will be 1 by 2a into a squared minus a squared minus here 1 a goes. So, 1 by 2a to 1 by a square plus a square. So, 1 by 2a I can take out, will become 1 by a square minus a squared minus 1 by a squared plus a squared, and that gives me a squared plus a squared minus a squared. So, twice a squared, so twice a will go. So, a by s to the power 4 minus a to the power 4. Okay. It is very simple. What would be the Laplace transform of t squared e to the power minus a t cos omega t? Okay. T squared e to the power minus a t cos omega t. Now, Laplace transform of e to the power minus a t into e to the power minus a t into f t is how much? F t is multiplied by e to the power minus s t for integration. Along with that, you are having e to the power minus a t. So, it will be s plus a. So, f s plus a. So, if we take only this part, what will be the Laplace transform of e to the power minus a t cosine omega t? So, s plus a by, very good, s plus a whole squared plus omega squared. Okay. Now, in the morning we discussed t into f t. If I take the Laplace transform, what was it? What was t into f t? Minus f s by d s, is it not? Therefore, t square f t, so it will be plus d square f s by d s squared. Okay. So, t square into this will be second derivative of this. Therefore, Laplace transform of t square e to the power minus a t cosine omega t will be d square of this function s plus a by s plus a whole squared plus omega square. You can do the derivation. Okay. second derivative of this you can extract. So, that will be the Laplace transform. Next, t to the power half, this is a very different kind of function. You have, if you have already been exposed to gamma function, gamma n is 0 to infinity e to the power minus t, t to the power n minus 1 dt. Okay. So, t to the power half, t to the power half, Laplace transform of this will be 0 to infinity t to the power half e to the power minus s t dt, and t to the power half can be written as t to the power 3 by 2 minus 1. I will write in this form t to the power n minus 1 e to the power minus s t dt. Okay. So, I can take s t as a variable, s t as some t 1. So, dt will be t 1 by s. Okay. So, t to the power half will be t 1 to the power half by root s. So, this can be written as 0 to infinity t 1 to the power 3 by 2 minus 1 by root s. Okay. T to the power half can be written as 1 by root s into t 1 to the power half. So, dt will be dt 1 by s. So, e to the power minus t 1 dt 1 by s. So, I get s into root s, s to the power 3 by 2 into 0 to infinity. What is this? Gamma 3 by 2. And gamma 3 by 2 is gamma n will be n into gamma n minus 1. Okay. Therefore, this one will be 3 by 2 into gamma half divided by s to the power 3 by 2. Okay. So, 3 by 2 gamma half is root pi. This is a standard result. We are not going to the proof of it. Gamma half is root pi. So, 3 by 2 root pi by s to the power 3 by 2. Okay. Next, what would be the Laplace transform of e to the power minus a t squared? You may go into the start from the beginning, from the fundamentals, 0 to infinity e to the power minus a t squared. This is one approach. Then this gives me e to the power minus a t square plus s t into dt. You may adjust some terms to get some t plus alpha whole squared, okay, in that form, and then take out something in terms of s, and then integrate. Okay. This is one approach. There are standard results like e to the power minus x square dx. What will be the integration of this is a standard one. So, if you can bring it in this form, you can evaluate this. The other alternative is a very simple straightforward approach. Take e to the power minus a t square as a series 1 minus a t square plus a square t to the power 4 by factorial 2 and so on, and then take the Laplace transform of individual terms, that is one will give me 1 by s minus a t square will give me a by s cubed, that is all, factorial 2. So, I will write 2 plus a square t 4 by factorial 2 t 4, what will be this, factorial 4 by s to the power 5 and so on. Okay. You can write the series. Now, you are given some functions like this. A periodic function, say 0, 5, 10 and so on. Say this is 10, it is continuing. What will be the Laplace transform of this? So, for this what you do? You take only the first element, first period, and determine its Laplace transform. What is the Laplace transform of this? You break it up into standard functions. This is a ramp function plus, what do I do here? If I apply a negative ramp, will that be all right? Should I add anything more? If I add a negative ramp of the same slope, here the slope is 10 by 5, 2, is it not? Slope is 2, here it should be minus 2. If I start subtracting, then it will remain there. So, I will have to also subtract another step function of what magnitude? 10. Is that all right? Minus 10. So, what will be the Laplace transform corresponding to the first element? 2 by s square. Second one 2 by s square shifted by 5 seconds. So, e to the power minus 5s. Next minus 10 by s e to the power minus 5s. So, this is the Laplace transform of the first element f1s. If it is coming repeatedly, then fs will be f1s into 1 plus e to the power minus 5s plus e to the power minus 10s and so on, is it not? So, that will be a GP series f1s divided by 1 minus e to the power minus 5s, okay. 1 minus the common ratio, and f1s is this much, substitute that. Okay. Let us have another example. What would be the Laplace transform of this function? This is a sinusoidal function, but it is truncated at 90 degree and it continues 0, 4, 8, 12 and so on. This is the maximum value, this is 10. So, this is the first part. If I write it, this is a sine wave given, this is a sine wave and this is the maximum value 10 sine omega t. So, you are chopping at the maximum value, that means corresponding to 90 degrees. So, what will be the breakup of this? What are the components that will be adding up to this? 10, it will be 10 sin omega t, and what is omega? 2 pi by t. What is that period? 16. Okay. 10 sin 2 pi by 16 t is this one, plus at this point you are adding a negative function, and what is this function? Cos. So, plus this will be 10, will it be plus or minus? Minus, because it has to be subtracted, minus 10 cosine 2 pi by 16 t minus 4 into u t minus 4. I am not writing that, it is implied. Okay. So, this plus this will give me this one. So, if I write f1s as the Laplace transform of the first element, that will be equal to 10 sin 2 pi by 16 t. So, how much is it? 2 pi by 16 divided by a square plus 2 pi by 16 whole square, minus cosine of this will be giving me s by a square plus 2 pi by 16 whole square into e to the power minus 4s. Is that all right? Because it is a shifted function. So, f1s is being repeated every 4 seconds. So, what will be fs in terms of f1s? Straight away f1s divided by 1 minus, because it is all plus. So, in the GP series sum it will be 1 by 1 minus e to the power minus 4s into f1s. f1s is this. Is that all right? So, whenever you come across such terms 1 by 1 minus or 1 plus some e to the power minus tau s, it is a periodic function. So, if you drop out that term, rest of it will give you the Laplace transform of the first period. Okay. Next, a periodic triangular wave. So, this is 5, 10, 15, 20 and so on. This magnitude is given 20. So, once again let us take the first period. You need not take one period, you can take just one half, okay. That is coming alternately plus and minus, all right. So, let me calculate the Laplace transform of this function. Okay. This one, how do you break up? A ramp of slope 20 by 5, 4, is it not? So, this is 4t, slope is 4, okay, plus what do I do? At 5 second, at this time, at the 5th second, what do I do? I add a ramp in the negative direction, and what is the slope of that? Double the slope, then only a line that was going up will be brought down to minus 4t. So, this slope is 8 minus 8, okay, and shifted by 5 seconds. Will that suffice? This plus this, will that give me this?
No,
After 10 seconds, after 10 seconds what do I add? Another ramp of what slope? If I add plus 8, what do I get? See, this plus this net result is 4. So, it would have continued with minus 4. So, now to bring it to the horizontal position I have to add only plus 4. So, slope is plus 4, alright. So, what will be the Laplace transform of these 3 components? So, F1s will be 4 by s squared, it is a ramp function, minus 8 by s square into e to the power minus 5s plus 4 by s square into e to the power minus 10s. Is that all right? Therefore, Fs is F1s into this is 1, next it is negative e to the power minus 10s, the whole thing is shifted by 10 seconds and given a negative sign. So, minus 10s plus e to the power minus 20s and so on. So, it is a GP series again. So, it will be F1s divided by 1 plus e to the power minus 10s. Is that all right? Common ratio is now minus e to the power minus 10s. So, it is this. There are a few more problems. Okay, there is an interesting problem. Let us see. You have an exponentially decaying function as the envelope of a pulse train. It continues. This envelope is e to the power minus t by 2. This is the envelope, that is you are having rectangular pulses, periodic pulses like this 0. So, this is 0, 1, 2, 3, 4, 5 and so on. This has been multiplied by e to the power minus t by 2, an exponential function, to give you this product. Okay. This and this multiplied together has given me this exponentially decaying pulse. What will be the Laplace transform of this function f(t)? F(t) is basically f1t into f2t. What will be the Laplace transform of this f1s? What is f1s? It is one pulse 1 by s into, if I consider only the first pulse, it will be 1 by s into 1 minus e to the power minus s, okay. Then that gets repeated every 2 seconds. So, it will be the geometric series, the sum will be e to the power minus 2s. So, that gives me 1 by s into 1 by 1 plus e to the power minus s, this can be written as e to the power minus 1 minus e to the power minus s into 1 plus e to the power minus s. So, that will be simplified in this. So, what would be f s if a function is multiplied by an exponential function e to the power minus alpha t, where alpha is 0.5 now, e to the power minus alpha t, alpha is half 0.5, then s will be replaced by s plus half. So, it will be 1 by s plus 0.5 into 1 plus e to the power minus s plus 0.5. Is that okay? Is this all right? Another example, now you tell me what would be the Laplace transform of this function 2, 2, this is t. What would be the Laplace transform of this? How do I break it up first of all? I can, since it is starting from 2, I can write like this plus a ramp like this. That means this is 2 by 2, the slope is 1, all right. So, this is minus 1. So, from a step function, if I keep on subtracting a ramp of this slope, I will start getting this. It would have continued. So, at this point I should add at 2 second, this one start at t equal to 2 seconds, this will start, okay, with the same slope plus 1. So, what would be the Laplace transform of this? It will be 2 by s minus 1 by s square e to the power minus 2s. Is it? Nothing, it is starting from 0. What about this one? Plus 1 by s square e to the power minus 2s. So, that will be the Laplace transform of the given function. Okay. Another function we take exponentially decaying function, then again this is b, this is a, this is c, this is 2c, it is going to minus b again, then minus a, and so on, it keeps on repeating. Let us take this itself. If it is repeated, there is no problem, it is just a GP series we get. Let us see what will be the Laplace transform of this. So, let us find out for the first block. What is the Laplace transform of this? It is starting from b coming up to a in time c. Okay. So, how do I write like this? Write the equation for this. E to the power some minus alpha t is this. Now, at t equal to 0, whatever be this, at t equal to 0 it is always 1. So, it must be b times e to the power minus alpha t. If it starts from b, it has to be b into e to the power minus alpha t. Okay. And at t equal to c, what is the value? Its value is a, that is b into e to the power minus alpha c is equal to A. So, how much is alpha? Therefore, alpha c is log negative. So, it will be b by A, log of b by A will be e to the power alpha c. So, alpha c is this. So, alpha equal to 1 by c log b by A. So, if b, a, c are given, you can calculate alpha. So, the function is b into e to the power minus alpha t. Sorry? Alpha c is log b by A. So, alpha is just bring the c down 1 by c. So, what would be this function? That is, we have calculated alpha, that is the expression for this. We have not yet broken up into different components. So, this function can be written as this going up to infinity plus what? Plus what? A function which starts with the value a, but the same exponentiation, that is alpha t, all right. So, this one is b e to the power minus alpha t, and this one is a e to the power, what should I write? Alpha t minus c u t minus c. Okay. Because it is starting from a, it is the same rate of fall. So, alpha remains same, t is replaced by t minus c. Okay. So, what will be the Laplace transform of this? B by s plus alpha and minus a by s plus alpha again, but because it is shifted, e to the power minus c s. Is that all right? This will be the Laplace transform of this. I call it f1s. So, fs is, if the given function is only for these two parts and after that it remains 0, then what will be fs? It will be f1s minus, this is evaluated as f1s. So, this one is minus f1s e to the power minus cs, f1s e to the power minus cs. Okay. What about 2c? After that it does not come, nothing is there beyond 2c. So, do you feel 2cs, some e to the power minus 2cs term should appear somewhere in this? Is it not missing? It will come out of f1s. f1s has embedded in it, sorry, where is that f1s? Here, there is one e to the power minus cs. So, when it gets multiplied by another e to the power minus cs, so it will be e to the power minus 2 cs. So, that means after 2 seconds there is some termination. So, you can substitute the value of f1s from here and then see the result. Okay. Now, there is an interesting circuit problem. You are asked to calculate the current in these two circuits. Calculate the current in this circuit as well as current in this circuit. Before the switching operation, both these elements were neutral, there was no energy stored. Okay. This is R, this is C, this is R, this is L. Now, R is given as 10 ohms, L is 1 Henry, C is 1 microfarad. Okay. What would be the currents? Also, you are asked to calculate the voltage across the inductor and the capacitor. Now, you know, you can replace R, L and C by you are applying here a step voltage. First you are applying a step voltage and then you are applying different types of voltages that we have discussed earlier. Okay. That is, some of the voltages that we will be applying are, say, the triangular wave, rectangular pulse and so on. So, let us start with a simple voltage, step voltage. Vt is ut. Now, in the transform domain, I can write this as Vs, this will be R and this will be SL. And in the other case, I need not show the inductor anymore. The moment I put S, I might as well put just a block. Okay. And in the other case, it is, we discussed the other day, 1 by SC, is it not, for simple circuits. So, what will be the current? In the first case, it is Vs divided by R plus SL. Correspondingly, what will be VL, Laplace transform of this VL, small vl? It will be current multiplied by this impedance SL. So, SL into IS, that means SL by R plus SL into Vs. Okay. In the second case, it will be VCS. So, similarly, VCS will be when the capacitance is there. So, that current multiplied by the impedance. So, Vs by R plus 1 by Cs is the current multiplied by the impedance 1 by Sc. Okay. So, that will be Vs, if I multiply with this, RCS plus 1. Okay. So, let us take any of the functions, say I may take this one. Suppose this is the applied voltage, what would be the current? Applied voltage is this one. Okay. So, Vs is, if you remember, Fs was derived as F1s by this. So, F1s is known, where F1s is 4 by s square minus 8 by s square into e to the power minus 5 s plus 4 by s squared into e to the power minus 10 s divided by 1 plus e to the power minus 10 s. So, this is V s. So, let us take the simple value R and L 10 Henry, 10 ohms and 1 Henry. So, this one is S L by R plus S L, this is the voltage across the inductor into V s. Okay. So, S L, therefore, V across the inductor will be S L by R plus S L, which means L was 1 Henry into V s, and V s is this much into this whole quantity. Term by term you write S by 10 plus S into 4 by S square minus 8 by S square into S by 10 plus S into e to the power minus 5 s plus 4 by S square S by 10 plus s into e to the power minus 10 s, okay, multiplied by this sum of GP series. Okay. So, whatever is this final result in this bracketed quantity, whatever expression you have got, whatever is the time domain function corresponding to this, that gets repeated with alternate plus and minus signs. So, that can be that will come out of this. So, that can be kept aside for the time being. We will take Laplace inverse of this and then we will repeat that in that same fashion. So, it will be, what will be the Laplace inverse of the first term? S will go, okay, let me write in the simplified form, 4 by S into S plus 10, okay, minus 8 by S into S plus 10 e to the power minus 5 s plus 4 by S into S plus 10 e to the power minus 10 s. This can be broken up in a partial fraction form. How much is this? 1 by S minus 1 by S plus 10 gives me 10 in the denominator, all right. So, I can always write this as 4 by 10 into this minus 8 by 10 into 1 by S minus 1 by S plus 10 e to the power minus 5 s. Once again 4 by 10 into 1 by S minus 1 by S plus 10 into e to the power minus 10 s. This is corresponding to this bracketed quantity. I call it say P s, and then that will be multiplied by this. Okay. So, what will be corresponding current, the corresponding voltage corresponding to V p, this P part. So, if I call it V p t, which is only arising out of this function, it is basically corresponding to one period. If you remember, one period gives me this. So, So, what will be VPT? 4 by 10 into 1 by s gives me ut minus 1 by s plus 10 gives me e to the power minus 10 t whole thing into 4 by 10 minus 8 by 10 I am not writing it, it is multiplied by e to the power minus 5 s. So, whatever I get I will be delaying it by 5. So, it will be u t minus 5 minus e to the power minus 10 t minus 5 u t minus 5. Okay. The second part. Similarly, the third part will be 4 by 10 u t minus 10 minus e to the power minus 10 t minus 10 u t minus 10. Okay. So, this is whatever it is, this is the first period, and 1 by 1 plus e to the power minus 10 s means it is common ratio is minus. So, alternately it will be plus minus plus minus. Okay. So, it will be if VPT means this, therefore, actual VLT will be VPT minus Vp t minus 10 u t minus 10 plus Vp t plus 20 sorry t minus 20 minus 20 u t minus 20 and so on, alternately plus and minus. Is it okay? I hope you can solve it for the capacitive element also with different values. We shall be taking up some differential equations simple differential equation how to write in the Laplace domain d square y by dt squared plus 3 times dy by dt plus 2 times yt is equal to 5 times ut. This is the forcing function and this is the differential equation. You are asked to calculate yt by using Laplace transform. Okay. It is a second order differential equation. So, second order term, the second derivative you can write in terms of fs. So, ys. So, this will give you s squared ys. If you initially assume all the initial conditions to be 0, we will take up initial conditions later on. For the time being, let us take this to be 0, then this will be 3 times s into ys plus 2 times ys is equal to 5 by s. So, it is s squared plus 3s plus 2 into ys, which is 5 by s. So, how much is ys? 5 divided by s into s square plus 3s plus 2 can be written as s plus 1 into s plus 2. Okay. I can write it as a by s plus b by s plus 1 plus c by s plus 2, and taking the inverse of these three, I will get the final yt as a into ut plus b into e to the power minus t plus c into e to the power minus 2t, where a, b, c residues can be calculated from here by standard partial fraction technique. Okay. So, we will stop here for today, we will take it up in the next class with further examples using Laplace transform for network problems. Thank you very much. Good morning friends. Before we start our next topic, I would like to correct a small tutorial problem that we did last time. If you remember, there was a function t to the power half for which we are computing the Laplace transform. So, gamma n is this. Now, gamma n is basically n minus 1 gamma n minus 1. So, here it should be gamma 3 by 2, which is half, there was a slip here, it should be n minus 1 gamma n minus 1. So, it should be half gamma half. So, please make this correction, I am extremely sorry, it will be half root pi s to the power 3 by 2. Okay. Today we shall be starting frequency response of systems. Frequency response of various types of networks. What do you mean by frequency response? When we excite a system by, say we have a sinusoidal input Vm sin omega t applied to a network whose impedance function is Zs, all right, in the Laplace domain. In the time domain, we are applying a function Vm sin omega t. So, in the Laplace domain, this will appear as Vm into omega by a squared plus omega squared. So, this is our input function, Zs is the impedance function. What will be the output? Now, in this we may treat the current as the output. Okay. So, Is will get as Vs by Zs. We can write Ys into Zs. So, for any system we define Ys into Vs. Thank you. Ys into Vs. So, if Vs is the input and Is is the output, 1 by Zs is the multiplier, we call it a transfer function. Okay. So, input multiplied by a transfer function is the output. In this particular case, it happens to be 1 by Zs. The transfer function depends on how you define the input and the output. For a 2-port network, we may define output as V2 and input as V1. So, V2s by V1s will be the transfer function. Somebody may be interested in the current that is flowing under open circuit condition or maybe under short circuit condition. So, it is not necessary that it should be always V2 by V1, the transfer function depends on how you define the output. Okay. Now, we will evaluate right from the start what will be the output in the time domain and at steady state what will be the response like. When you see an image or when you hear a sound, if the energy of the sound or the light is just doubled, if you just double the intensity, the perceived intensity will be log of 2, in some logarithmic scale. That means, if I change the brightness, if I give the input energy to the light double the previous value, then I will not be receiving, I will not be feeling that the light has been doubled, the intensity has been doubled, it will be in a logarithmic scale. Similarly, when you hear a sound, if the energy of the sound has been doubled, then I will be receiving it as log of 2, the perceived intensity will be varying logarithmically. Okay. So, it is better to define a new gain function which will be log of the original gain function P2 by P1. We choose a base 10. Base is not so much important, we could have selected the natural log also, that will be giving just a constant. How much is that constant? Log of 10 to the base e 2.303. Okay. So, log of say V2 by V1 squared, that means basically twice log of original g. Okay. We call this unit as bell integers. When zeta is more than say how much? Okay, when zeta is equal to 1, when zeta is equal to 1, then it will be 1 by s squared plus twice omega n s plus omega n squared. That means 1 by s plus omega n whole squared. There are two real roots, two equal real roots. So, at omega n straight away there will be a 40 dB per decade fall, all right. Is that okay? At omega n, that means two roots are coming, if you remember, for different values of zeta, if you calculate the roots of this quadratic, okay, we will take it up in the next class, how the roots travel, how the roots are changing. For different values of zeta, the complex pair of roots will be moving like this, and then this is the time when they will become equal. If you increase zeta beyond this, the roots will be real, but they are separated now. Two distinct roots you will be getting. Okay. So, we will take it up in the next class, and then we will see how to make the phase plot from the gain plot.